Welcome to the latest edition of our Defense Developer webinar series. I am Gary Schofield and I will be your host today. If you have any questions through the webinar, please enter them in the Q&A module and we will work to address these at the end of the webinar. We will post the recording of this webinar soon afterwards and send you the link as well. Please also feel free to contact us afterwards if you need any help or have any questions. Thank you for joining us today for another webinar in our Defense Developer series. Today we are focusing on working offline. Our speakers are myself, Gary Schofield. I am an account executive on Esri's defense team, and I also am Esri's Commercial Joint Mapping Toolkit, or CJMTK, program manager. And with me today I have Carrie Robertson, who is Esri's product owner for defense and intelligence, and Parker Hornstein, who is a solutions engineer on Esri's defense team. Our agenda today includes a brief introduction, after which we will talk about using data in various formats stored locally on the device. Then we will get into using maps and web maps as a way to organize your data and make available more advanced functionality and business logic to your field applications. We will demonstrate how to use ArcGIS Pro to prepare data and maps to sideload on your device, as well as leveraging ArcGIS Enterprise to make maps available for offline use, as well as for syncing data back to the enterprise. Finally, we'll take your questions. Throughout this series, we have talked about the benefits of using a GIS and the modern architecture of a WebGIS in your C2 and intelligence systems. We have discussed the importance of not just digitizing existing paper workflows, but rather to use technology to transform our approach. However, one significant concern is how do we deal with disconnected, intermittent, and low bandwidth or DIL environments? We can't always rely on the network, so how do we push data forward to our edge devices and ensure they will have access to information with or without the network? In this webinar, we will be talking about how we support the field operations portion of this diagram, who may not have connectivity or at best only a tactical radio. It's important to understand that the concept of WebGIS does support these use cases. ArcGIS includes capabilities to easily deploy data from our enterprise to these devices for disconnected use. It also provides capabilities to sync data when there is a connection, so the operator can get new data from the enterprise and also provide their data back to the enterprise. What if you aren't building an enterprise application at all? ArcGIS Runtime consumes many data formats directly, so you can take advantage of powerful GIS capabilities directly in your embedded apps. In short, ArcGIS includes support for DIL environments and sees it as an important part of the enterprise and WebGIS. These field operators need the latest information to support their situational awareness, and everyone else needs the valuable data these operators can provide about what is really going on. First, we'll start today talking about what data formats are supported directly by ArcGIS Runtime. ArcGIS Runtime supports a variety of common data formats through layers. We have layers for many different web services that Runtime supports, but today we are focused on the layers that load directly on the device. Runtime supports the read and write of vector data in mobile geodatabases, shapefiles, and GeoPackages. We also have extensive support for the most common raster formats. We showed last webinar that we not only support basic display, but we can also apply various renders and functions to these rasters. We are constantly working to improve the functionality and layer support. For instance, we just released a 100.4 version of Runtime, which supports KML and Mr. SID. In update 5 in the spring, we plan to have write support for KML as well as read. Later in the webinar, we will spend time talking about the various packages you can make in ArcGIS and how they are used to simplify your workflows and provide additional business logics to your applications. Rather than talk more on this, I'd like to hand it to Carrie to show you the use of local data in Runtime.
Thanks, Gary. Okay, so I'm going to show you a whole series of demonstrations to demonstrate how we support several different types of local data formats in ArcGIS Runtime, from feature layers to raster layers to 3D layers, and then some standard data products as well as non-standard data products. So we'll start off here using the Dynamic Situational Awareness example app, which is written using the ArcGIS Runtime SDK for Qt. This is on a Windows platform. And I can show several different types of local data here. First, I'll start talking about feature layers. So Runtime supports several different types of feature layers, such as a shapefile. So I'll load in a shapefile here, and we can see it drawn to the map. We also support the GeoPackage specification. So I have some utility infrastructure data here that was created and packaged up into a GeoPackage. And if I look at one of these features here, we see that it is using the standard defense data model, capturing all of that information, but in this packaged format. You'll notice, though, that the symbology for these data sets is just using the default symbols, this kind of grayscale symbol set. And that's because the symbology isn't carried over with the features themselves. It's just really for data exchange. Another type of feature layer that we support is the mobile geodatabase. Here I have a mobile geodatabase of military bases. So I'll add that to the map. And you can see that in this case, because it's a geodatabase, this was packaged using ArcGIS Desktop, and it does include symbols such as these military symbols and then the buffers around each one of them. ArcGIS Runtime also supports over 20 different raster formats. One that I'll show here is an example of a QuickBird image that I can go ahead and add directly to my map as an overlay. This map is also in 3D. So we can talk about adding 3D layers as well. I have a DTED layer here. I could add that as an overlay in my map, but actually I'd like to include it as an elevation source because it does have that elevation data in it. So as I add it, you'll see that the resolution of the terrain here improves just a little bit. So now when I perform any kind of visibility calculations or other types of analysis, I'm getting the detail that's provided to me within that DTED data set. ArcGIS also supports scene layers or 3D layers. I'm going to add in here this scene layer package that was created from our friends at Vricon. It's an integrated mesh that's built on the I3S standard. This is a relatively new data type, and it gives us an effective way to generate more realistic 3D environment, and it uses overlapping imagery typically collected from drones, aircraft, or satellites. This is particularly useful for urban 3D modeling, as you can see by the incredible amount of detail that's provided over this area here. You can see the detail for each one of the trees and the buildings in the area. Now, since I'm talking about raster data, I'm going to mention the Mosaic Dataset. In ArcGIS, Mosaic Datasets allow you to store, manage, view, and query small to vast collections of raster and image data. It's a data model within the geodatabase, which manages collections of your source, image, and raster files on disk. We recommend using Mosaic Datasets when working with tiled data, in particular with standard defense raster formats, such as raster product format specifications like CIB and CADRG, as well as with DTED. ArcGIS Runtime supports Mosaic Datasets as a raster layer, whether it was created in ArcGIS Desktop or can also create these dynamically using the code in the application itself. Here's an example of a Mosaic Dataset of some raster tiles over San Juan in Puerto Rico. We can use ArcGIS Pro to create and manage the Mosaic Dataset, but we need to make sure that we export this Mosaic as a mobile Mosaic Dataset inside a mobile geodatabase in order for Runtime to work with it. A mobile geodatabase is a SQLite database, which is engineered for high performance use within the Runtime SDKs across all the platforms and devices that it supports. So in order to create a mobile Mosaic dataset, we use this geoprocessing tool here called Mosaic Dataset to Mobile Mosaic Dataset. So I just need to set some parameters. I need to point it at the Mosaic Dataset that I want to use as the source. It creates a new mobile geodatabase for me, so I'll give that a name. And mobile geodatabases have the extension .geodatabase. And then I can give it a name for the Mosaic dataset as well. There's also some additional parameters that I can set, and I can go ahead and run this. And what it does is it creates this new mobile geodatabase here, but then it also keeps those images as source files in a separate folder. So when you deploy this to your application or to the device where your application is going to be run, you need to include both the mobile geodatabase and the images themselves. So I'm going to switch over to a simple app that I have on my Android tablet here. First, I'm going to show you how this data is sorted on the device that's going to be used in the demonstration. I have a folder here called data, and in it you see that mobile geodatabase and the images that are used within that mobile geodatabase. But I also have the source imagery too, because I'm going to show two different workflows. The first one's going to be adding that mobile Mosaic dataset that's within the mobile geodatabase that I just created. Another one, the other workflow, is showing how you can actually create a new mobile geodatabase and mobile Mosaic dataset in code pointing to rasters that are on disk. So I have a folder here called TIFF that has 5 of those 6 tiles in it. And then I have another folder here called new tile, which has the 6th tile in it. So I'm going to show the workflow of creating one with only some of the rasters and then adding new rasters to it. So let's move over to the demo. This is a simple application focused for these workflows. It was written using the ArcGIS SDK for Qt deployed on Android. So first I'll go ahead and browse to the data set. So in my data folder, it's the San Juan geodatabase. And we can see that it's adding all of those tiles here directly to the map as a raster layer. Now when I click this Create New Dataset button, it's going to unload that existing raster layer, and it's going to create a new mobile geodatabase, and then it's going to look for all the tiles in that TIFF folder and add them to a Mosaic dataset that's in that, to a mobile Mosaic dataset within that mobile geodatabase. So see how quickly that was done there. It's added those 5 tiles in. Now when I hit add tile to dataset, it's going to perform the same function, except it's going to look for that additional tile and add it to the dataset. So we thought it would be important to show you this workflow because lots of times you're working with these tiled datasets. You might need to be able to receive updates while you're in the field, either updated imagery or additional tiles. And it is, the Runtime SDK does provide you with the means to do this. Let's switch back to my desktop here, and I'm just going to show you some of the code that was used in order to do this. Because this was written using the Qt SDK, this code is using QML. So there's a couple buttons here that I showed. There was one called Create New Dataset, and in this code, it does 2 things. It creates, it uses an existing mobile geodatabase that it had created when the app started, and then it creates a new mobile Mosaic dataset in that mobile geodatabase. And then it calls this function add rasters to MDR, and that passes it the path to that TIFF folder, and then it adds those rasters in. The other button here was add tile to dataset, and that doesn't need to create that Mosaic dataset. All it needs to do is add rasters to MDR, and it's the same function that's called again. It's just pointing to a different path that has that extra tile in it. So if we look at that function add rasters to MDR, here we go. It's actually an asynchronous function. So ultimately what it calls is this add rasters function on the Mosaic dataset. This is what you do to call, to dynamically add rasters in. Before we do that, we set some raster parameters which specify that the path to where the tiles are and the filter that's used. Once that's done, it signals that it's been completed, and then we create a raster layer out of that Mosaic dataset. And once it's loaded, we change the viewpoint to point to where that data set is, and then we add it, we append it as an operational layer in our map itself. So it's fairly straightforward to make that work. Now I'm going to switch over to another machine, actually over to my, my Macintosh. Let's see, okay, there we go. Okay, so here we're looking at the sample viewer for the ArcGIS SDK for Mac OS. Runtime supports several standard data products such as ENC or KML. ENC, or Electronic Nautical Charts, is based on the IHO S57 standard. It's typically used in onboard systems and for marine navigation. ArcGIS Runtime supports displaying S57 data using the S52 portrayal standard, which gives a lot of flexibility in terms of how the data is displayed in these environments. So I can control the rendering style from day to dusk to night and back again at will. That's because those are defined within that S52 portrayal standard. Also, as I pan and zoom around, we can see some of the detail that we get in this data set. I can add some miscellaneous features such as beacons and buoys in restricted areas. But also for some, it's very important to be able to focus on specific depths. So we have the ability to focus on 2 meters, 5 meters, and 10 meters. Now let's look at the code for this. First of all, we create an exchange set and we point it to where that exchange set is on the device itself. Within that exchange set, there can be data sets, and within data sets, there's ENC cells. So first we discover the data sets that are within that exchange set, and then for each one, we discover all the ENC cells. We load them as ENC layers, and then we add them, in this case, to the base map. So we're doing this because lots of times ENC works well as a base map, giving that kind of contextual information that you need for operations. Runtime also supports KML as a KML layer. This is a KML data set of current flight information over Northern Europe. It contains network links to show the latest information for this flight data. So as I zoom in here, you can see some of this information. Runtime takes care of making sure that the data pulled down from the network links is kept up to date. This is actually 3D information, so we can render it using a scene. Now, if we look at the code for this, so first of all, we create our scene view. Then we use the URL of the KML dataset itself to create that KML dataset. In this case, the KML is hosted in ArcGIS Online, but it could also be a file that's on disk. And because it has network links, we create this network link message handler in order to understand that network link message traffic that's happening. And then we add it as a KML layer and then append it as an operational layer in our map. Now that's for standard data formats. Sometimes though you work with data formats with maybe non-standard geospatial data formats, but it still might contain pertinent information that you need to display in the map. In this case, we're rendering data that's contained within an XML file. It contains control points of information for the geographic features, as well as military symbol ID codes to render the symbols correctly. If we look at the code here, what we're doing is we're creating a graphics overlay in order to store and display this information. What we do is we create a dictionary renderer, as you can see here, that's based on a dictionary symbol style that is pointing to the MIL standard 2525D style file. And then after we've done that, what we need to do is parse that XML file where we discover the control points for all of those geometries. We add them into a graphics overlay. And once that's done, we append that graphics overlay to our overlays within the map itself. So Runtime provides several flexible ways of adding maybe not well-known formats within your map. It doesn't have to be only these standard formats. Okay, so that's some examples of how we work with local data. I'll pass it back to Gary now to talk about other ways to work with maps.
Thanks, Carrie. Now we want to look at not just working with data offline, but working with maps offline. So first, let's talk about what is a map. Maps and scenes for 3D gather resources and configuration you need to tell your story in a document that can be opened, shared, and edited across ArcGIS, whether you're working in a desktop, web, or mobile environment. These geographic documents combine a base map, layers, symbology, data tables, elevation sources, and bookmarks. So it is much more than just a grouping of data sets. For example, you saw when Carrie loaded that GeoPackage, it didn't come with symbology, but when she used the mobile geodatabase, she could capture symbology and rich cartography that she designed maybe in another application. And so it can carry that information with it and make it a much more usable and user-friendly application. The other thing you'll notice is when she clicked on that information, you saw a pop-up with lots and lots of kind of empty fields and information that may be hard to read. With a map, you can actually design your pop-up to be much more human readable and provide the right information to your users to make it a much more pleasing, pleasant experience and also more informative when they click on features in the map. Maps can also contain analysis capabilities such as locators to support geocoding and search, as well as network analysis for routing applications. Rather than build the map in code in runtime, you can take advantage of the powerful map-making clients such as ArcGIS Pro or the portal for ArcGIS Map Viewer. This greatly reduces your development effort and sustainment tail. You can easily change the map to add new data or change the way it is visualized without changing anything in your application code. You can also easily use the same app with many different maps for different users and missions. Another nice feature in working with maps in ArcGIS Runtime is that we have designed Runtime to work with both online and offline functionality with nearly the same code. There are, of course, some differences. For example, you use geodatabase feature table class when edits go directly to a local geodatabase, but you use an edit session API with service feature table class when you need to apply changes to a feature service. On the whole, though, your code is the same because you're working with the map, whether it is online or offline. In this webinar, we are focused on the use of maps offline. We have two major offline patterns with ArcGIS Runtime, the services pattern and the desktop pattern. The desktop pattern is about creating and managing your data and maps in ArcGIS Pro. You then package these maps and sideload them to your device for runtime to use. The services pattern takes full advantage of WebGIS in an ArcGIS portal, either through ArcGIS Online or more likely in defense examples using ArcGIS Enterprise for an on-premises solution. Although we talk about this being a services pattern in WebGIS, it's important to understand that this pattern supports connected, disconnected, and occasionally connected modes. In this pattern, your maps are built using ArcGIS Pro or authored directly in Portal and shared into groups to those that need them. ArcGIS Runtime apps can then just discover and use these maps directly. However, you often have to take these maps offline to support the disconnected and sometimes connected modes. We have developed specific capabilities in the ArcGIS platform and runtime to easily support taking a map offline and to even update that map in the underlying data. We have two workflows for taking web maps offline using the services pattern. The pre-planned workflow is where you define specific areas of the map to make available for easy download by your clients. For example, you may have specific areas of responsibility for your deployed units, which you designate and then set a schedule for when these areas are packaged for download, maybe every night. This is a good workflow if you have many clients that will request the same areas over and over. It greatly reduces the load in your server and speeds up the process for users to get their data. On-demand workflow allows a user to select their area of interest and packages the map on the fly for delivery to the client. This will take additional processing and time, but it allows more flexibility for your users if you aren't sure what sections of the map they will need at any given time. So let's look a little bit more detail about the desktop pattern. In this method, you use ArcGIS Pro to manage your data and compose your maps. You then package that map up into a mobile map package. It's important to understand this capability is a one-way send to the client because the mobile map package is then just side-loaded to the device. You can later replace that map with a new map package should the data or map change. If you need a data set to provide context for your own data, Esri offers Street Map Premium for ArcGIS, which provides a high-quality base map as well as locators for searching addresses and places, and a network data set to allow for routing in the application. If you want to deploy your own locators and network data sets to your applications, you will need to use this desktop pattern to do so. Let's take a look at this pattern with Parker.
Thanks, Gary. So what I have here is I have a collection of features of vector data that was given to me in support of a humanitarian and disaster response operation focusing around San Juan, Puerto Rico. Now, the data contained here are things like heliports, hospital locations, and major key buildings. For the user on the ground, we want this to be able to operate in a disconnected environment. So what I want to do is package this up into a mobile map package. Mobile map packages consolidate your maps into a single file. This file can be shared online through your ArcGIS Online organization or copied directly to a mobile device in a disconnected environment. First thing I want to do to go ahead and package up this data is I want to remove the base map. I'm only interested in the vector information at this point. I open the Share as a mobile map package tool, and I'm prompted with a few items to fill in. The first thing up top is it prompts me of whether I would like to package this for online account or save it to a local file. Because I want to operate in a disconnected area, I'm going to save it locally. I'll give it a brief summary. I'll give it a tag so that I can find it later. I also have the option to clip the extent of the data that I'm pushing out, so that if I don't want to send my full map out as a large data set, I can clip it down. And I can include a locator if I'm doing some routing. Since I'm not, I'll go ahead and analyze, and I find that I have no errors, so I'm ready to move on. The runtime to compile this vector data is about 5 minutes, so I've already run it to save us a little time. I can open it up in this simple sample viewer. This sample viewer is built with the Runtime Java SDK, and I can interact and see my features. The symbology is retained, and I can generally work with it. Now, what I want to do is I want to push this out with a routing capability. As Gary mentioned, we offer StreetMap Premium as a premium service. And what this is essentially a base map containing network datasets. These network datasets are roads, highways, pathways, etc., that using our routing capabilities, you'll be able to navigate on. So what I've done is imported that data, and I've simply added my vector features on top. And again, I have the same data that I've already packaged up once, and I've just added a routing capability. I'll again open the Share as a mobile map package tool. I'll save it locally. Tag it again. And this time, since I'm only interested in a certain portion of Puerto Rico, I'll clip the features to my current display extent. I also want to include a locator so that people doing routing will be able to find a specific location from the application in a disconnected environment. I analyze, find I have no issues with it, so I'll go ahead and package it up. The runtime to compile this larger data set of all of San Juan is about 35 minutes. And this is a little heftier because we're including layers of routing. Those are dense networks for the device to be able to do routing on in a disconnected environment. And we're also including the locator. Locator is pretty hefty, and it allows people to search for specific addresses in the application. And once I export this, I can share this out locally. So I already shared it over to Carrie, who's going to demonstrate what it looks like on a mobile device.
Okay, thanks, Parker. So I'm back on my Android tablet. I'm actually using Navigator for ArcGIS for this portion of the demonstration. This is a professional ArcGIS app for mobile navigation, but it was built with the ArcGIS Runtime SDKs for Android and iOS. So you could build a very similar application to get a similar experience to what we have in Navigator. So we'll see that I've received that mobile map package from Parker, and it's located on my device. I can choose to open it. And we have all of that data here presented as Parker had packaged it. Now, this app has a very specific purpose, just to really give me directions from one position to another. So if I choose another location on my map, I can get the address information from there because the locator is included. And then I can ask to get the route to that location. We see it drawn on the map, and we also get our turn-by-turn locations. So now do we not only have the map and all the rich symbology and other information included with the map, but we have this other capability to perform analysis on it as well, which is quite powerful. Okay, so now we'll switch back to the slides. I'm going to talk a little bit about the services pattern. So when you use the services pattern, the main thing here, as Gary had mentioned before, is that it works with the web map. And so you author a web map as you normally would by either creating a map in ArcGIS Pro and publishing that to your enterprise or to ArcGIS Online. And once you're there, you need to make sure that that web map is enabled for offline use. And what that means is you have to look at all of the different sources of information that are included in the web map and make sure that those are configured for offline use. So there's some specific steps to follow if you're working with raster and vector tile services. And similarly, there's steps that you need to follow for feature services. But no, in this pattern, you also need to use the desktop pattern in order to take locators and network data sets offline. You can't include them in the web map and package them up at this point. So you'd have to use a similar workflow to what you saw with Parker, and those can be side-loaded and used together with a map that's taken offline. Okay. So just take a little look at the code here that you'd have in runtime. The first thing you need to do is to connect to that web map. And so you can connect to it directly by using the item ID for that map itself, or you could allow the user to browse to the map that they want to use. Once you have that, then you set it as the map you want to use in your app. Okay, so let's take a look at some of the steps we need to take to make sure a web map is enabled for offline use so that it can be used in both the on-demand and the pre-planned workflow. So I'm here in my map viewer as part of my the portal, and we're looking at the web map of the same data that Parker just showed. We've taken that map package and we published it up to ArcGIS Online, and it's now available as a set of hosted feature services that we've brought into this map. Now, in order to make sure it's enabled for offline use, we have to go to the map's item page within the portal. And within that item page, you need to click on the Settings tab. And we see here that we have a set of different settings that we can change relating to the web map. But the key thing to notice here is that if it is ready to be enabled for offline use, you would see offline listed up here next to web map. And once that's there, you can go in and change some additional settings. So the very fact that I don't see offline there means that I need to do some additional work to enable all of the layers that are part of that web map for offline use. So here we're looking at the item page for that feature layer that contains all of the feature services that are used within the web map that we had published based on that map package. If I go over to the Settings tab, just scroll down a little bit to the feature layer settings. The first thing we need to do is we need to make sure that we enable this feature service for sync. And that enables this disconnected editing and synchronization. That's the key thing that we need to do on these feature services. There's similar types of steps that you need to perform on any raster layers, but in this web map, we only have these feature services themselves. Okay, so now that that's done, and make sure you save it so it's part of that feature service. When I go back to the web map item page in the Settings tab, I'll just refresh the browser here. Okay, and you'll notice now it says offline. So now we can get to the offline settings for the web map because it's done all those checks to see if the layers that are part of that web map are also enabled for offline use. So if we click on that, we come down to this offline section. The next thing we need to do is we need to check it to make sure that it's enabled for offline mode. And from here, we can go ahead and modify some additional advanced options if we'd like to. I'm just going to keep the defaults. Once we enable it for offline use, we need to hit save. And that's the main thing that needs to happen. Now the map can be taken offline, at least in the on-demand mode, which is what we'll talk about next. Okay, for the on-demand workflow, the basic workflow that needs to happen here is that you do, just like I showed you, you author the map, you make sure it's all configured the way that you want to use it with the rich content, the pop-ups, the bookmarks, whatever else you need, and enable it for offline use. But then for the on-demand workflow, it's actually the client that's written that needs to request that map to be taken offline. So it makes a request to the server to generate that mobile data, to package it up and create that offline cache. And then once that's ready, then it can download it to the client itself. Once it's downloaded, then it can be used to visualize the information, to collect new information, and then any of the updates that are made can be synchronized back up to the server when you're connected again. All right, so let's take a look at the on-demand workflow. I have here a UWP app that was written using the ArcGIS Runtime SDK for .NET. And this is a live view of the web map, the same one that we were looking at in the portal map viewer earlier on. Now, in order for the on-demand workflow to work, you need to provide it with an extent. In this case, I'm going to zoom to the extent that I want, which is here over Old Town San Juan. And You can provide it with some other parameters as well, such as the scale range that you want to use, whether or not to include the base map or the attachments, etc. Then go ahead and ask it to generate and download the map area. So it's making the request to the server now, which is doing the job of packaging up all of that data and making it available so that it can then be downloaded by the app itself. And this is all performed as part of one operation. While we're waiting, because it could take just a little bit of time for that to work, let's look at the code. So the code here, the main thing is that you need the offline map task. You create the offline map task pointing to the web map that you want to take offline. Then you can specify what parameters need to be used. You definitely need to provide the area of interest, that's mandatory, and then the other parameters are optional. They are set with some default values. Then you go ahead and create that job that's going to handle that task of generating that map and downloading it once it's ready. And then you can track the progress as that's being made as well, so that the user has some indication of how far along the progress is moving. And then once that result is ready, you can then make sure that your application is using that downloaded map as the map itself. All right, let's see where we are with our download progress. Okay, so it still is probably finalizing packaging up that map. Okay, and now, yep. All right, there we go. So now this is the local map package that's on my device. And you see it includes all of the features that were within that extent itself. So we'll switch back to the slides to talk about pre-planned. For pre-planned map areas, these are things that you can define in the web map itself when you're back in that portal environment. As Gary had mentioned, there's lots of reasons why you might want to do this. Maybe you have several of your users for that client application who are only going to be working in specific well-defined areas, so you can predefine those. You might want to save the load on the server then in that case, where it's not generating these maps in an ad hoc sense throughout the day. You can create those caches in the evening time or once a week. You can create a schedule for when you create those caches, or just do them whenever you need to create them. And once those are created, then as the client connects to the web map, it can request what map areas are there, and then all they have to do is download it. So if we look at the workflow for pre-planned map areas, so first you need to author that map, you need to author the web areas. It needs to also be enabled for offline use, similar to it was for the on-demand workflow. And then when you author those map areas, it goes ahead and creates that the mobile data, that offline map cache. And then when the client connects to the web map, it can request if there's any, if the map's able to be taken offline, and then if there's any pre-planned map areas that are available. And if there are, then you can just request to download it, and it does download it directly to the device itself. And then once it's there, it can be used in a similar way for collecting information and synchronizing back up to the server. So the code for this scenario also uses the offline map task. So you can create that, and then using that task, then you make the request to discover what the pre-planned map areas are. So once you discover what those are, you can allow the chooser to pick which one to use, and then you can ask it to download that offline map into a specific folder, and then you add that to the map itself. So let's take a look at the pre-planned workflow. Back in our app, we can see we have a simplified user experience for the pre-planned workflow. We can select a map area from the list and choose to download it. And it's really as simple as that, because all it has to do is make that request to the server and download the map, which was already generated on the server. So we can see here, there's all our features for that area, and the base map has just been clipped to the extent that we wanted. But let's go back and take a look at how you create one of those map areas. So back in the browser, we're on the settings tab for the web map item within Portal, and specifically in the offline settings. So earlier on, we had enabled it for offline mode, but in order for the pre-planned workflow to work, we need to specify our areas, our map areas. So we have 3 that's already been created that we saw in the app earlier on. If we go into manage our areas, we can see the 3 that are here. I can go in to any one of those and update settings, manually refresh it, delete it. But in this case, I'm going to create a new one. So I'll drop the map area here over Old Town San Juan. Give it a name. And now for the level of detail, I'm going to say I only really need from the city level down to the buildings level. And at this point, I can also specify when I want those packages to be updated for downloaded. So essentially when they're refreshed. I can do that on demand, or I can do it according to a schedule. So I'm going to go ahead and create. And so what it's doing here is similar to what was happening in the on-demand workflow. It's discovering what feature services were part of the map, and it's making requests to them to actually generate those the caches of the information that can be downloaded to the client later on. So now we see we have our 4th area listed here. If I go back to the app, we see that this 4th area is now listed. And once it's done packaging, I'll be able to download it and use it. Okay, so that's the pre-planned workflow. I'll hand it back over to Gary to summarize.
Thanks, Carrie. As we've shown today, there are several different patterns for using geospatial data in your embedded native applications using ArcGIS Runtime. As Carrie showed, Runtime supports direct use of several common geospatial data formats. However, we encourage you to explore the use of web maps to simplify your development effort and enable your field application capabilities. These patterns allow you to author your map in ArcGIS Pro, ArcGIS Online, or ArcGIS Enterprise, and then deploy them to your device, which can take to the network or not. I want to thank you for the time you have spent with us today. If you have any questions, please submit them in the Q&A component of the webinar. Also, please provide feedback on today's session as you close the webinar. So let's see what we have. The first question is from Troy. It's, is the native Mosaic dataset demo part of the SDK samples? Do you know, Carrie?
No, it's not, but it is something we have on the list to develop in the future. So we know that's the common workflow that people ask us about. So you should expect to see it in a future release.
Great, thanks. Also, Anthony asks, in the desktop pattern, how do I package my base map for offline use? Parker, can you take that one?
Yep, so the pattern you would use to package up your base map is you first actually need to create a vector tile layer. The mobile map package packages up all data of the same type, so you're unable to mix the raster and the vector. So if you export a vector tile layer of the section of your base map that you want, and then add it back into the map with the remaining vector data, you can package it all up and share it.
Cool, thanks, Parker. Another question from Jeremy asks, can the mobile map package workflow handle offline edit sync so we can allow both locators and editing?
Yeah, using the mobile map package is read-only.
Desktop.
Yeah,
yeah,
the desktop workflow.
Still only read-only. Yep. Okay. The other question is from Patty, who asks, in the services workflow, can you clip to your chosen extent? Carrie?
You can't in the services pattern, and there's a few reasons for this. Usually, and one of the reasons why you want to use the services workflow is that you want to edit the data when it's on the client. So if you want to edit the feature data, you don't necessarily want to clip the features to an extent. You probably want the whole feature there. So we don't do that. But if you don't have that workflow, there might be some other clever ways, either on the server side or on the client side. When you make the request, you can exclude certain layers. If you know, maybe you have some big, like for instance, in the San Juan data we were looking at there, we had a big administrative area that covered the whole extent that we, but it wasn't really a feature that was included in the sub area that we wanted to download. So we could just choose to exclude that when we download the layer itself, or you could clip the data once it gets down onto your device. So at this moment, there are no plans to be able to clip that cache, that offline map cache.
Okay. Thanks, Carrie. We have another question from Jeremy about the number of pre-planned offline areas that are supported. I guess we've had a limitation of 16, but they have concerns because there's many that they have thousands across the US. Do you know, Carrie?
Yeah, that's a good question. I don't know the answer to that. I'm sure that right now it's creating those pre-planned map areas. It probably depends on what you're using to create them and the capabilities of your back-end servers. I'm not sure if our plans are to increase that or not, but that's something we can check on and get back to you.
Great. I think, so Gabriella has a question about attempting to use the desktop pattern to package the world navigation map, but ultimately having issues where the layer type is not supported in runtime content. She's asking what could be causing such a problem. I think the issue there is that the base map you might be using has to be enabled for exporting tiles. And actually, I think going back to Parker's demonstration, I think you have to package the TPK separately when using the desktop pattern. Is that right?
Yes, you need to package the base map as the tile pack itself, unless you have a vector tile base map, which should work.
Yeah. Okay. So that's probably something we can follow up with you, Gabriella, and see if we can provide some further assistance with that as well. Okay, I don't see any other questions. If you have any, please send them in. Otherwise, we'll wrap this up. Again, I want to thank you for your time this afternoon and for joining us. I also want to make you aware that this is the last of our Defense Developer webinar series. If you missed any of them, please go to the website and you can get the recordings. And we appreciate your feedback on the series as well as any subjects you would like to see us cover in the future. We plan to host additional webinars and events in the coming year as well. I'd also highly encourage you to consider going to one of our developer summits where hopefully you can meet people like Carrie and other people we've had on the webinar series and really engage with Esri developers, because we always want to hear what about your stories and your workflows and what you're trying to do so we can make the tools better to support you, and you get a lot of learning while you're there as well. So we have many events coming up with a Dev Summit in Berlin in a week, but it's never too late to register and go, so plan on that. And then in December, we will have a developer summit on the final day of the Middle East and Africa User Conference in Dubai. And in January, our federal GIS conference will be going on, and we will have a developer summit with that on January 31st. And then we, of course, have our marquee event in March in Palm Springs, which I really recommend that you make plans to attend. So thank you again for your time, and we hope to talk to you soon. Thank you.